provide for my followers. It's like being an Instagram influencer, but
monetized.
Maybe I should be an Instagram math teacher influencer.
Honestly, you might.
Honestly, you could be like a cool,
You might make it.
math teacher.
They called me cool, guys. All right, they've already skipped on. Okay. So yes, I forgot to record, so we're repeating this. So we're doing rational functions. We're looking at asymptotes. We're looking at where it takes us to where we have to pick up our pencil for discontinuity. Okay. Domain we've already looked at. We're like, what can X not be? We've already talked about those in the last sections and whatnot. You already have this part too in your notes as well from the beginning of this chapter. Discontinuous versus continuous. Again, those of you virtual, I've already gone over it in class. I just didn't press play. So y'all can look through those as well. Okay. Phew. Hold on. All right, here we go. So the types of discontinuity that you can have. What is going to cause me to pick up my finger or my pencil to continue on the rest of the graph?
Sorry, I was waiting to start.
Okay, come on in.
Thank you.
Okay, so what is going to cause me to pick up my pencil or my finger? Can I get a hold of you? Very. No problem. Okay, so things that can happen. We can have a horizontal asymptote. Again, horizontal. We can have a vertical asymptote. Vertical. And we can have what's called a hole in the graph. We can have all three. Okay? We can also have what's called an oblique asymptote. But I can't show you that because I have a horizontal asymptote up there. And we'll get to all those definitions here in a second. These are all different places that cause a space or a jump in the graph, if you will. This is definitely something you need for pre-cal, and it's absolutely something you need for calculus as well. Y'all ever seen Mean Girls? The movie?
Yes.
Where they say the limit does not exist. You'll use a lot of this stuff for the limits and everything like that because the hole in the graph, and if you have to jump, there's all kinds of stuff with that. Okay. So again, we have horizontal, vertical asymptotes. We have a hole in the graph. We could have what's called an oblique or slant asymptote. We'll get to that here in a second. The math side of today really isn't hard. It's the remembering all the details before you even find that, okay? So let's look at vertical asymptotes first. When we say we cannot divide by 0, that's what's creating a vertical asymptote. When we say we can't divide by 0, that's that boundary line that says, nope, can't come here. Because if you get x equals 3 anywhere on your function, you'd end up dividing by 0. Okay? So like I said, we've already done this one a ton of times. Okay? Vertical asymptotes, we are going to set our denominator equal to 0. I'm going to switch pages here. I'm going to come back to this one. I'm going to try and make a page like I was making on the whiteboard earlier. So vertical asymptotes, I'm going to set the denominator equal to 0. Okay, so that's the first thing we're looking at here. I'm trying to make a one page for y'all of just this chapter so you can see what I'm talking about. Okay, so vertical asymptote, we're going to look at our denominator because that's where we're finding restrictions on our domain. So that's where we're going to find all of those issues. Okay. First, what I want you to do is factor my denominator, like we've been doing on every single problem. Back to the denominator.
Pardon the interruption. Teachers, there was a bus that was involved in a car accident this morning. Those children have just now arrived at school. Please admit them to your class without a tardy pass and do not count them tardy. Thank you.
You went to that much extreme, then you made the front office believe it too? That's impressive.
Yeah, he actually crashed the bus.
Oh, don't say that.
Well,
Wow.
I wouldn't say it, so it wasn't true.
Donna's actually notorious for
It's an elaborate story there.
On the stage.
Hey, why would you crash the bus?
I know, that's what I did. Did y'all hear? Because I even got the front office to participate.
Yeah, I wasn't on it. They were about to pick me up. They were like a half mile probably away from my house.
Was it bad?
No.
Yeah.
I mean, unless the back was really like, I saw it from like a side.
Was it two buses? Was that what that picture was?
It was, their same bus, different angle.
Oh.
I'm glad you're okay.
Yeah, me too.
Why did you-
Crash the bus.
Okay, so two numbers that multiply to get 3 but add to get -4.
-1, -3.
Okay?
Just
So, to find your vertical asymptotes, we're just going to set our denominator equal to 0. So, we're used to writing x can't be. We're just going to write that our vertical asymptotes are x equals 1 and x equals 3. Okay? If you actually graph this in your calculator, you would get this graph over here to the right. All right? So if you notice at 1 and at 3, I have these almost invisible lines that make restrictions for me, okay? So vertical asymptotes are just these like little dotted lines that say, hey, I know you said I can't equal 1 and I can't equal 3, so these are your boundary lines. You can be anywhere else but that, okay? So that's what you are finding in terms of this graph. Okay? So on the next slide, this is the same as number 1. It's just repeated. But we're going to look at least 3, possibly 4 different ways you could see this. So like I said, we've already done number 1. I'm just going to write that in there real quick. It's on your notes as the last thing you did, but I'm going to write it over here so y'all can see it. Okay. Now, this right here is how we're going to find a hole in the graph. Okay. So the past couple of days, we have found if something is the same, we cancel it out, right? Okay. If you cancel something out, that is what creates that little hole in the graph. Okay. So let's look at Why don't y'all go ahead and try 2 and 3 and tell me my vertical asymptotes for those. 2 and 3, tell me my vertical asymptotes.
This is Mr. Stevens.
Okay, so number 2 probably set up a red flag. At least hopefully you set it up. If I subtract 1, I get x squared equals -1. I take the square root of both sides. What's the square root of -1? I. Now, I get it. These look like imaginary lines, but they are not allowed to be imaginary numbers, okay? So if you come across a situation like this, where when you set the denominator equal to 0 and you get an imaginary number, for your vertical asymptotes, you're gonna put none, okay? Even though they look like imaginary lines, you cannot have imaginary vertical asymptotes. So if you think about it, what we're creating is where I can't have a number that plugs into x that gives me 0. I can plug anything in the world in for this x right here, and I still won't get 0. Okay, well, except for positive and negative I. All right, but this like actual real numbers, plugging those in, nothing will make that denominator 0. So in this particular case, I would just put vertical asymptotes. There aren't any, okay? So if you have your calculator, let's go ahead and plug this into y equals. Just want you to see what these look like, especially since you're going to get to use your calculator a lot for this test. When you get to pre-cal, you'll do these more by hand. So if you notice, I don't have to pick up my pencil at all to draw the rest of this graph, okay? So there's no vertical asymptotes that's keeping me from continuing on what I'm supposed to be doing, all right?
Did you plug in
I'm sorry?
Did you plug in number 1?
No, I plugged in number 2. Number 1 was already on that last slide.
I did what you got number 2.
You didn't?
No. Maybe it's because I did.
If you do the division button, put parentheses around your numerator and your denominator. Okay? So the first one, we had 2 vertical asymptotes. The second one, we have none. All right. Now the third one, if I factor this, I get x minus 4 and x plus 1 all over x minus 4. Can I cross something out? Yes. Since I can cross this out, this actually means I have a hole at x equals 4. Okay? Not a vertical asymptote, a hole in the graph. Is there anything left in the denominator after I cross that out? No. Okay? So since nothing's left, to answer the question they originally asked me, do I have any vertical asymptotes, I would put none as well. So I don't have any vertical asymptotes, but I did have a hole at x equals 4. Okay? Now, plug that into your calculator. So y'all are, I'd say a little bit younger than me, right? A lot of it. A lot of it. It's okay.
You're 24.
You're right.
Oh.
I'm an old hag, 33.
Oh, come on.
The 30s. I do have a cool birthday though. It's 8/7/87. My sister-in-law is 8/6/86, so my brother's got it good. He doesn't have to remember a whole lot. All right, so with your little young eyes,
Yes.
can you see the hole in the graph? Everyone does.
No.
No.
As I ruined my eyes because I got extremely close to my calculator.
So here's the thing. You're going to get to use your calculator, but visually, you wouldn't have seen, you would have been like, oh, no vertical asymptotes, no holes, no points of discontinuity. Done. I'm done. You'd be wrong, okay? What you can do, however, is look at your table. Now I can see that. All right? I can see the word error. Notice how it says error at x equals 4. It's telling you, hey, there's a spot in the graph where you cannot be. And that's where that hole is, okay? So if you're getting to use your calculator, you need to know how to use it, all right? So the visual graph, which, sorry, virtual kids, hold on, I'm coming in. They said they're like, you talk about the calculator, but then you don't show it. So here, I'm not able to see that there is a hole in the graph at 4, but what I can see when I plug it into y equals, and I go to my table, what I can see there is that they tell me there is an error at 4. Okay, so that's what I'm looking for because I can't see it with my own eyes, but the table tells me it's there. Okay, so just be careful of that. All right, yeah.
So I understand why if there's a 0 in the denominator that creates vertical asymptote, but so why when those cancel out, why does that create a hole? Like I understand the concept, but why does it do that?
So you're saying even though we canceled it out, why is it still causing a problem?
Well, so why does canceling it out cause a hole?
Oh, okay, I get what you're saying. Because technically, once you simplify this, like we've been doing the past couple of days, you're left with just this. So when you graph just this, you get a line. But still from the original problem, you have a domain restriction. That's why I had y'all every single one of those problems before you told me like what cancels. You had to tell me what X can't be because it's still a domain restriction. And then when it's canceled out, then you have the simplified form there. That's what you'll graph. But it still had a problem. So that's what the problem is. But it doesn't cause a vertical asymptote. That is ones that stay on the top. Okay. Because they still, even though we have simplified the equation, there's still an issue. They're still there and they're still causing a problem. Okay. Let me go back to my one cheater here. Whoa, there we go. So notice how I bumped that one to the top. Because if I cross something out before, that's what I'm going to do. And then what's left over is the possibility of a vertical asymptote. Okay? So, horizontal asymptotes. Y'all are going to make fun of me. Y'all are going to think I'm weird. But y'all are not going to forget them. Okay?
Is there a song?
No, there's not a song. Unfortunately, there's not a song. But it sings.
Freeland? Freeland? You're written point?
All right, so horizontal asymptotes are horizontal lines. But notice at the bottom here that's covered by the recording, you can only have one horizontal asymptote. Vertical, we can have multiple. But horizontal, we can only have one. And with this particular one, we can cross it. So the difference is vertical asymptotes are a restriction on a domain. Okay, we can't cross it. Horizontal asymptotes are kind of like a little guideline. There aren't any restrictions that it's causing, but it's more of like, hey, I'm just going to give you a guideline of where you're going to graph this kind of thing. So that's why you can technically cross a horizontal asymptote. Vertical, no way, no shot. Can't do it. I don't know how well that one works. There's an electric one up there if you want to use that. Okay, so like I said, there's some weird stuff with these. All right, so I don't want to write all those mouth words. Not what I'm really into right now. What I do want to look at is some basic words that are going to help me remember this. All right. What I mean by that is we're looking at the degrees. So back on that one cheater, horizontal asymptotes, I am comparing the degrees. Okay. I'm comparing the degrees. We'll go purple. Okay. So what I'm going to do is I'm going to look at who has the highest degree. Okay. Remember, with the degree, it's the highest exponent, but we're going to look at the numerator versus the denominator. It's like a battle of the century, right? Okay, so for the first one, it says if the degree of the numerator is higher than the degree of the denominator. Wah, wah, okay? I'm going to say top wins. Weird. I'm going basic words here. Top wins. Numerator wins. Top wins. Okay? Numerator has the highest degree. So what that would look like is I would have like x to the 5th over x cubed or something like that. See how the numerator has the highest degree. Okay? So if the numerator has the highest degree, aka top wins, then I say, no way, top can't win. Because you're going to have no horizontal asymptote. And when we get to examples, it'll make a little bit more sense there. Okay, hop. Yeah, no hop is what I said. This is where that oblique asymptote comes into play. We'll come into that here in a minute. So, if the numerator has the highest degree, I say, no way, top can't win. Another way you can look at it too is, and you'll see why here in a little bit, if you say, oh, the top one, no. Okay, you'll find yourself doing that too. Okay, no way, top can't win. All right? So if the bottom wins, aka the denominator, I say yo at the bottom. Why? Because your horizontal asymptote is just y equals 0. Get it? Yo.
Get it, yo?
You can laugh all you want to,
I ain't laughing.
but this will help. Okay, so if the bottom wins, aka the denominator has the highest degree, then your horizontal asymptote is just y equals 0 every time. So that would be a situation like x cubed over x to the 5th. Okay? And the last possible outcome you could have if it's a tie. Okay? In other words, you have x cubed over x cubed. Okay? I always say, let's share, or we have to share, or something of that nature. And you're going to put, and I'll put an example over here which will make more sense. If you have x cubed, let's say you have 4x cubed over 7x cubed. Maybe there's other stuff with it too. Then your horizontal asymptote is just going to be y equals 4/7. You're going to put the leading coefficients over each other. Okay? So when it's a tie, they have to share their leading coefficients. And that is your horizontal asymptote. Okay? All right, so back at my one sheeter. Top wins. I'm gonna, whoops, wrong one. I'm going to put no horizontal asymptote. Okay. Bottom winds. I'm going to do yo at the bottom, so y equals 0. And if it's a tie, you're going to do y equals leading coefficient. Let's see if I can make this work. Over leading coefficient. Okay. So those are my 3 options for a horizontal asymptote. Okay. So far, to find a hole in the graph, I cross out the factors, set them equal to 0. Vertical asymptotes, I'm going to set the denominator equal to 0. Horizontal asymptotes, I'm going to look at the degrees. Top winds, no horizontal asymptote. Bottom winds, y equals 0. It's a tie, leading coefficient over leading coefficient. Okay. All right, let's try some examples. Okay, I just want you, these are the same problems we've already done. I just want you to tell me the horizontal asymptotes on these. Just the horizontal asymptotes. Haha. Easy when it's right next to it, but just remember you have to know those for the test. Okay, let's look at the first one. Who wins? Bottom, yo at the bottom. So this is a 1, this is a 2. So my horizontal asymptote is just y equals 0. Who has the highest degree on number 2? The tie. Let's share our leading coefficient. So this is a 1 and this is also a 1. So 1 over 1 just gets me 1. Okay. Who has the highest degree on number 3? Top. No way. Top can't win. Okay. So I would put none. Okay. Now, because we don't have the horizontal asymptote, there's a possibility for an oblique asymptote. Okay? And that'll be the last one we learn. Let's take a quick break. And then we're going to put all of it together.
I was trying to see, which one is this one that you were putting in? The adding, subtracting one? Let's see.
I think I did it wrong.
That's okay. I thought I saw it on the alert that that was. Okay, so do you have your phone? Hey Dane, we're usually leaving my show and tell on this. Will you show real quick
Oh,
submit? That'll have y'all's app.
I mean,
you and my phone or something?
I don't know, I thought, okay,
So there's like a Canvas app that you can really have for you.
alright,
Oh, you already got it? So the whole
The Academy's tracking.
okay, so like,
You can get it on the internet. Get it on the, do you want the Wi-Fi?
yeah.
the password, it's my son's school lock on the password is in there.
Oh, okay,
Yeah.
it's very difficult.
Yeah, it's been that way since like,
The best part was is they kept that from us. And like then later on, the kids were like, hey, the password just said that. And we're like, oh, thank you for telling us.
Alright. Which one though?
the one with, because that's on, the other one. You, it's like, what's,
That's okay.
camera.
Use photo.
Sure, they're JPEGs.
Do what?
They're JPEGs from the phone, so.
Okay.
Just click submit. Thank you.
Hey guys,
Did you get it?
it's loading, let's see.
Alright, thank you, Mr. Chapman.
You're awesome. Yeah, absolutely.
Punctuation is horrendous. Look. Punctuation is horrendous.
are you in?
Yale, PA.
And are you a junior?
Yes, ma'am.
Okay, thanks. You on my roll.
Okay, but that's not actually even bad, it's just still like, it's still good. Yeah. It's like, what? Trillion?
Thank you.
Stop. It took so long for me to realize that imagine trying.
Yo, why did I not like think about how like just subliminally racist the Reese's Puffs commercial was?
Okay,
sorry.
let's, cut it.
What?
Maybe on your own time, friends.
Wow, right.
All right, let's come back. Let's go over oblique asymptotes real quick, and then we'll just do a bunch of examples until we don't have time to do any examples, okay? So the oblique asymptote can only happen when you do not have a horizontal asymptote. That's covered over here, sorry. So an oblique asymptote can only happen when you do not have a horizontal asymptote. Okay? They can only be 1 degree apart. So if you have x cubed over x squared, that's no horizontal asymptote, and they're 1 degree apart. So there's an oblique asymptote. Okay? If they are 1 degree apart, if you notice, it's a line. It's a slant line. So we need x to the first power in our final answer. Okay? So why would I say that when you get no way top can't win, I said you're also going to be like, no. Okay? How you find the oblique asymptote
Yeah.
is long division.
My second favorite division.
Okay? So in order to find what the oblique asymptote actually is, you have to do long division. Okay? That's why I said you'll get through a problem and you'll be like, horizontal asymptote, okay, top wins. Oh. Okay, here we go. So this can only happen if we do not have a horizontal asymptote. Okay? I'm going to go back to my one sheeter for a second. And I'm going to say 1 degree apart. Would that be 2 words or 1? Like that? 1 degree apart, long division, okay? Let's change that up. Get a different color going here. We'll go, ooh, that's a pretty color. All right, so probably should write what it is too. Okay, so if we are 1 degree apart, no horizontal asymptote, we could have an oblique or a slant asymptote, and we're going to find that by doing long division. Okay. So this is what you need for this whole section. Okay. You have to know all of this stuff. All right. So we're going to use that here in a second. So we're going to use it now. I'm going to put it next to the page we're doing. Okay, so I want to know everything. I want to know, is there a hole in the graph? If there's a vertical asymptote, there's a horizontal asymptote, or if there's an oblique asymptote. I want to know all the points of discontinuity that could possibly happen in number 1. I'm going to do that one with you. So what I would do is I'd probably give myself a spot for every single one of those answers. I put a hole, vertical asymptote, horizontal asymptote, and oblique asymptote. And then all I have to do is plug in my answers. Okay. How do I factor the denominator here? Difference of squares. So that just becomes 1 over x plus 4 and x minus 4. Okay. Here we go. Did I cross anything out? No. So I'm going to put none. These are the things that some of y'all are saying, hey, I need to remember this stuff. Some people are like, I need to definitely go back and revisit this stuff. Maybe write down the questions that I'm asking you that y'all are able to rattle back to me. Okay. What I mean by that is on your notes, I would write where I just said, did I cross anything out right next to holes? I would put that. Did I cross anything out? Question mark. So vertical asymptotes. I look at my denominator. So I would set those equal to 0. I get -4 and 4. Horizontal asymptote. Who has the highest degree? Bottom. Yo at the bottom. Y equals 0. So the good news is because I put something there, the next one's going to be none no matter what. Because I put y equals something, my oblique asymptote is going to be none no matter what. Okay? Oblique can only happen if you have no horizontal asymptote. Okay? Go ahead and try 2 and 3. remember too, if I look at my denominator, I know that if I set that equal to 0, and I do my first step of subtracting 3 over, that's be a big red flag, but that's gonna be an imaginary number. So automatically, I know I'm not gonna cross anything out, so I won't have any holes in the graph. I'm not gonna have any vertical asymptotes. I'm dealing with an imaginary number. Who wins on the horizontal asymptote? It's a tie. So again, this one's still leading coefficients are 1, so y equals 1. Because I wrote something there, I'm going to put none. Okay? So make sure if they're asking you about all those that you're still telling me none is the answer. Okay? Don't just leave it blank. Okay? Over here, I can factor my denominator. I get x plus 1 and x plus 2, which if I cross out my x plus 1s, that means I'm going to have a hole at x equals -1. I still have something left in my denominator, so I have a vertical asymptote at -2. Looking at the original function, who has the highest degree? Bottom, yo at the bottom, so y equals 0, which means I am not going to have an oblique asymptote. Okay, yeah.
I just want to make sure I heard you correctly. So you use the original degree, not the side degree.
You use the original to compare the degrees. We're going to look at some examples where I'm going to have it already written like this. And then it's up to you in your mind to say, well, if I multiplied this together, I would get x squared. So, yeah, I look at the original. Questions on those? Yeah.
So, for the vertical asymptote, so you use the like crossed out form. Instead of just the
Uh-huh. So if it's crossed out, it's a hole. It's not a vertical asymptote anymore.
So
Yeah, that's its own ball game. It is no longer a vertical asymptote when it is crossed out as a whole. Good question.
I think this makes a lot more sense now that we get into the other stuff. I don't know what I would have done with toughest first.
And why?
I know, right?
Yeah, that's-
Do what?
yeah, I just want to put this in here.
Yeah. Could you imagine? I'm glad I mistakenly did that. Okay, try these 3. Like I said, I want to do as many examples as possible so y'all can be exposed to all different types, and hopefully those things start clicking that I'm not like making up these little sayings for nothing.
It's for our own enjoyment.
Right. Well, that's just me teaching you math in general.
Yeah.
And obviously.
Obviously. Now, there is one that will have an oblique asymptote in these examples, but give it a shot, see if you can. I'm going to also go through how to actually find the oblique asymptote. Wait, number 4? Oh, when you cross it out, it is just a whole, isn't it? Right. Mhm. Right.
How would you write the oblique asymptote?
Just like that. I was gonna go over and down it just like that. All right, so on number 4, I can't cross anything out. So my answer for having a hole in the graph is none. But I do have 2 vertical asymptotes. I have one at x equals 1 and one at x equals -3. So if I was to multiply them together, I don't have to, but if I did, I would have x squared on the denominator. So who has the highest degree? Bottom, yo at the bottom, so y equals 0, which means I'm not going to have an oblique asymptote. Okay. Down below, I cross out my x minus 2's, which means I have a hole at x equals 2. I still have something left in my denominator, so I have a vertical asymptote at x equals -3. Who has the highest degree? Bottom again, so y equals 0, which means I do not have an oblique asymptote. Okay. So number 6. If I factor this, I get x plus 1, x minus 1, all over x plus 1. My x plus 1's cancel, which means I have a hole at x equals -1. Do I have a vertical asymptote? Nope, nothing's left. Who has the highest degree? No. Okay, so since I wrote none there, I have to look at it and say, well, now, are they 1 degree apart? Well, 2 versus 1, they are. Okay, so I'm going to have an oblique asymptote here. In this particular problem, it doesn't work out every time, but in this particular problem, they've actually given you the answer. Because if we're going to divide these out, it's right there. But if we didn't, and in some cases it's not going to work, you're going to have to do long division. So if I take x plus 1 and I go into x squared minus 1. Let me extend my page so y'all can see it. Okay, so then I'd say 1 times x gets me x squared. That's just x. X times x is x squared, and x times 1 is 1. X. Draw my line, change my signs. I get negative 1x minus 1. And I know I can multiply by a negative 1. Now, in some cases, you will get a remainder. Okay? In some cases, you will get a remainder. In this particular case, we didn't. No matter what case it is, what's that stand for? What does it stand for? I don't care. In every situation, when you're finding the oblique asymptote, I don't care about the remainder. Okay? The remainder means nothing to me. All right, so the question is, how do we write our answer? This part right here. You'll just write y equals x minus 1. This one went into it evenly. It's not going to be that situation every time. This one worked out perfectly. Okay? And that's why I said it kind of gave us the answer anyways. Just scroll up now. It gave us the answer anyways because right there. Okay? But in any situation after you do long division, if you get a remainder, who cares? You don't use it, you don't need it. So if this remainder was maybe 4, I would still write y equals x minus 1. Okay, remainder does not matter. Questions on those 3?
Just to clarify, so
Okay.
you only do long division when the degrees are 1 apart. If it's
So
not,
you-
there's no.
Right. So you could still have the numerator win. But since that's 2 apart, notice how it's called an oblique or a slant asymptote, which means that's a line, which means it needs to be x. Can't be x squared. You don't have a slant asymptote that looks like that. You're like, well, I don't know. I've never seen these graphs before. But you don't, okay? So that's why it has to be 1 degree apart, because when we do long division, we need it to be able to give us an equation of a line, because we want to be able to graph an equation of a line. Okay? I don't want that one. Okay, let's try these 3. Same thing. Tell me whole, vertical, horizontal, oblique. I want to get to the level where y'all are sick of doing these problems. That means you understand it.
I must understand really well.
And I know that's smaller that I have the screen split. So if you need help on what something says, let me know. All right, so for the first one, did we cross anything out? Nope. Vertical asymptote, we look at our denominator, so we get x equals 3. Who wins on the horizontal asymptote? It's a tie. Now, this case, it shows a little bit better of the property. So we would put 2 over 1, which gives me y equals 2. So since I have a horizontal, I'm not going to have an oblique. Okay, so I put 2 over 1, which is just 2. Okay. Got a little overzealous over here. Didn't give myself some factoring room. Okay, so I have x minus 2, and then I have x minus 1, plus 1, and x minus 3. Can I cross anything out? Nope. So that means my vertical asymptotes are going to be -1 and 3. Who has the highest degree? Bottom? Yo at the bottom, y equals 0. So that means none here. Okay. Our last one, we're not crossing anything out. Sorry, that was a tease. Last one on this page. None. Vertical asymptote is what? 5 over 2, 2.5, however you want to say it. Just don't fall victim to just looking at the 5. Okay, that 2 still is a part of it. Who has the highest degree? Top. Ugh. Okay, so we do not have a horizontal asymptote. Are they 1 degree apart? Yeah, they are. Okay, so we're going to do 2x minus 5 into x squared. Okay, here we go. 2x times what is going to get me x squared? 1/2 x. So 1/2 x times 2 gets me x squared. And then minus 5/2 x. Draw my line. Change my signs. So then I get 5/2 x. So what do I multiply 2 by to get 5/2 x? Huh? So if we do 2 times 5/4, we get 5/2. Okay, so yes. So plus 5/4. So we get 5/2 x. And let's get serious. The next part I don't care about because that's going to include the remainder and I'm not interested. So my oblique asymptote, as ugly and weird as it looks, is y equals 1/2 x plus 5/4. Okay. I know fractions are tough, but they're also numbers too. Okay. Questions on those besides the fractions? I mean, you can ask about the fractions. I was just saying, is there anything about the process? Okay. Let me see if there's anything crazy on the next 3, and then we'll see if we need to do them or not. Not really. I think we're good here. All right, so this is on the top of your homework sheet. That's the 8-3, okay? This is the last section anyways, so make sure you have all of that complete. And then tomorrow we're going to do a slight review where we take our quiz, and we're done for fall break, okay? So if you're someone that's missing assignments, I'd get them done so that way you can enjoy your fall break.
You know what, Ms. Chapman?
What is it?